Today, what is today? The 22nd. So we continue with 1.5. So we looked at the power rule. Okay, which, let me refresh your memory with an example. Let's say x to the third power prime.
X squared.
Very good. What about x to 4/5 prime? It's slightly more difficult because I have to work with fractions, but the power rule is the same. I bring 4/5 in front. I write x, and from 4/5 I have to subtract 1. 4/5 minus 1, what do I get? 4 minus 5 over 5. Okay? Which can be rewritten as we know. Do we all agree with this? It's okay if you disagree, and I'll show. If you need me to show again.
Sorry, you got that again. I forgot how to do that.
Yes, if the power is negative, it goes to the denominator. Every power that is a fraction, it's a radical. We had this discussion last week on R.5. So every power that is a fraction, it will always be a radical. If the power is negative, the entire quantity goes to the denominator. If the power is negative in the denominator, the entire quantity goes to the top. Is that better?
Slightly.
Okay, maybe you want to review R.5 from last week?
We don't have to in class.
Okay.
I'll just review it.
Okay. Good, that was the power rule. Now, let's say we have a function plus or minus another function. Remember, we had a property like this with the limit in front. What do you think this equals to? So it's similar to that property with the limit of f of x plus g of x. What do you think? Wild guess. F prime of x plus or minus g prime of x. Let me refresh your memory on the property I was talking about. Do you remember when we talked about the property of the limit of x, f of x plus the limit of g of x as x approaches a? We said that this is the limit of f of x as x approaches a plus the limit of g of x as x approaches a. So this was a limit rule, one of the properties of limits. So I was getting to, yes?
Professor,
yes?
I don't remember we having this. Did we have this?
The limit laws?
Yeah, this one here you just explained. I don't remember I have any notes. I don't know. I don't know, maybe I missed that one. You don't have to show me.
But now I'm testing my memory now. Remember, I told you what my best professor was saying. When you get to the stage when you have to write it down, then you forget where you wrote it down. So now I have to check myself.
I don't know what my classmates think. Do they remember having this?
Yes, I think.
Okay.
I think it was briefly mentioned.
We had all the limit laws discussed. We had to. But let's check. Sorry, different class. Sorry. Sorry, it's February the 9th. Okay, I got a chat, so maybe.
I don't want to take up your time,
No, but
other people's time. It's okay.
no, but it's very important. Why does a canvas
Because they don't
jump?
want to
Why
teach
does it jump like
Okay.
that? So I have the book right here. So
9:30.
the limit laws, 1.1, we talked the numerical, and they have to be in 1.2. I'm checking my memory too. Algebraic limits, of course. But why not? Let's briefly look because this is very important. When and also we've been using them without even thinking, actually.
I'm surprised I missed that.
That's okay. Let's look. Am I in 1.2? No, I'm checking myself now. It's okay. Thank you for telling me that. I'm looking for. I mean, if no one remembers this, then obviously I have to check myself. Okay, this was last time.
It's gonna be on 9:13.
Thank you. I always have to be very careful because there is a lot of overlapping between your class and my 191 class. So I need to make sure that I present everything correctly. So you said here, I thought I did click on this, or maybe I didn't. Because I remember we didn't finish everything, and when we started again the following time, we continue with those limit laws. Here it is. Okay, so I didn't lose my mind yet. Limit rules or properties. Assuming that both functions have limits, L and M, they exist, they're numbers. Here it is. The limit of the sum is the sum of the limits, or the difference and difference, product. And then I asked you about the ratio, and then I asked what is the if, because there is an if here, big if. And then we talked about a factor, and then we talked about the continuity and the swapping of the operators. This is touching the function, and this is second, but now this is first and this is second. And the same thing here. And then we talked about polynomial functions and how to determine the limits for polynomial and rational. Thank you.
I'm so sorry.
No, it's okay. Let me say this again. If you see something or think that something is wrong, you may be right, I may be wrong. So it never bothers me. Okay, so even if you're just having doubts and it turns out that I'm correct, it's fine. I'd rather go back and check. Thank you.
Thank you.
My pleasure. So what this property says, what this rule says, is that if I have two functions that I need to differentiate, I can differentiate the first function, and then if I have plus, I put plus, and differentiate the second function. If I have minus, then I write minus. So this is a similar, that's why I try to go back and connect concepts so it's easier for you to remember. That's all I was saying here. Okay. Now I would like to practice these and then move on. Okay. I'm going to open the book. Go back to the book. Where is my book? Okay, it's not here. Where is my book? Okay, we want to go to 1. We want to go to 1.5. And then I'll explain the name of Leibniz notation in a minute. Okay, we are on page 154. Thank you, Tess, for helping me with finding the exact. I thought I was in 1.2, but I had to go one step back. Thank you.
You're welcome, my pleasure.
It saves us time. So we want to be 154. Okay, so next one. Let's choose anything we'd like to find each derivative. So that's the question. From 43 to you name it. And before we do that, I just want to say one more time here, just give you an example, a little example. So let's say we have a boss that we work for, and this is the factory revenue. Or, I don't know, profit, whatever. So in January, let's say this is January, our boss comes to us and says, how is my profit doing? Is it increasing? Is it decreasing? And on this function, we're going to go here, and we're going to find the slope of the tangent, or simply find P prime for January, and say, boss, the revenue profit is positive. But then in February, we go to the boss and say, watch out, your profit is still positive, still increasing, sorry, but the rate of increase is smaller than it was in January. This is smaller, the slope of this line is smaller than the slope of this line. In January, the profit was increasing much faster, at a faster rate than in February. This is smoother. This is much faster. So we will say to the boss, careful. Your profit is still increasing, but at a much slower pace. And then we're going to say, I don't know, in August, well, your profit is not changing. But then we're going to say in December, oops, your profit rate of change is negative. So you should have done something here. Okay, so that's the idea with the derivative function. Okay, so now let's choose from here and work on this, and then move on to other rules and a word problem. Okay, ready? So we want to find the derivative. So let's choose anything you want.
56.
56, got it. I'm copying it. 56 on page 155, and we have y equals 1 over 3x to the fourth, and they're asking us to find dy over dx at x equals -1. So now let me explain this notation. This is a useful notation. It's a fancy way of saying, you know, y or f of x is the same thing. It's a fancy way of writing f prime of x. The derivative of y with respect to x, dy over dx. In that case, we have to use a vertical bar, and towards the bottom, write x equals -1. This is a more complicated notation, but it's useful. And it's the same with this for when x is -1. Do you have to use it? Not at this point necessarily. You can just say, I'm denoting y by f of x, and I'm finding f prime of negative 1. Same thing. Or you're using dy over dx when x equals negative 1. So first of all, let's find the derivative. And this is what we call the Leibniz notation. Okay, so we have y equals 1 over 3x to the fourth. Remember what I always say. Factor, simplify, no negative leading coefficients, no always descending order. I don't touch anything before I simplify. Can I simplify this in any way? Of course. Let me show you. And I will always do it. Why? Because now y prime or f prime of x or dy over dx, they all mean the same thing. Everything is the same. The derivative of y, the derivative of function because y and f of x are the same, or dy over dx using Leibniz notation is the same thing. The constant stays outside. I bring down negative 4 and subtract 1 from the power. This is the same thing with negative 4 over 3x to the fifth. Is this okay? So far, we haven't finished, I know. Everyone okay with this?
Can you repeat it again?